It's in pajamas. Boop, boop, boop. Alright, guys, so today we're going to be talking about something called relative velocity. Now, gotta lay down. What relative velocity is let's say you are standing here and you're just standing still, but you see a ship moving in the water, and you see people moving on the ship. How does their velocity appear to you? That's what relative velocity is. The velocity of something, in this case a person, relative to someone outside the system who is viewing it. So let's take a look at this, shall we? Yeah, first problem. So a spy runs from the front to the back of a ship at a velocity of 3.2 meters per second. If the ship is moving forward at 27 meters per second, how fast does the spy appear to be running when viewed from the shore? So let's go ahead and draw this scenario. So we have the ship. And the ship is moving forward with a velocity of 27 meters per second. We have a spy who is running from the front to the back of the ship. And he is running with a velocity of 3.2 meters per second. And we have to find the relative velocity. So if someone is standing on the shore, how fast does it appear that the spy is moving? Well, we know that the ship is moving forward with a velocity of 27 meters per second. So this is the ship. And since it's heading forward, we can give that a positive value. The spy has a velocity of 3.2 meters per second, but he's running backwards. So since that is in opposite direction, we can give that a negative sign. So the relative velocity equals positive 27 plus negative 3.2, and that will give us 23.8 meters per second. So it appears as if the spy is running forward, or it appears as if the velocity of the spy, not that he looks like he's running, but his velocity is forward 23.8 meters per second. Which makes sense because even as he's running back towards the back of the ship is still moving faster than him. So even though he's moving and running that way, because the ship is continuously moving this way, it's going to make his velocity appear different. Now let's do one more relative velocity problem. So a ferry is crossing a river. The ferry is heading north with a speed of 4.2 meters per second. The river's current has a velocity of 5.7 meters per second east. What is the ferry's relative velocity? So let's diagram this out, shall we? So the ferry there he is. He is moving north, and his velocity is 4.2 meters per second. So this is the river. He's going from one side to the other. But the river has a current, and that current is pushing the ship with a velocity of 5.7 meters per second east. So for someone standing on shore, how does it appear? What is the relative velocity of the ferry? Well, between the force of the ferry being pushed, we can figure out its relative velocity the same way we would find the resultant. So we know R equals square root of 5.7 squared plus 4.2 squared. And that would give us 7.1 meters per second. And since that is velocity, that is a vector, we need a direction. So we can figure out our theta. So theta equals inverse tangent of opposite over adjacent, so the y value over the x, 4.2 over 5.7, and that will give us 36.4 degrees, since we're standing here. This is east, north of east. See, not too bad, right? All right. Well, I hope this helped you to understand relative velocities a little bit more. If you have questions, hit me up in our Google Classroom or through email or our actual classroom. You know, it's all good. But in the meantime, you guys, stay awesome, stay amazing, and stay safe. All right, talk to you later. Bye-bye.